Okay, so lesson 3.2. So today we are going to be talking about writing expressions that are given certain information, interpreting algebraic expressions given the context of a problem, so real world stuff, and evaluating and simplifying expressions. So we're going to start with the classwork. So first thing that we need to talk about is some vocabulary. So it has these words. The amount of money that a business needs to spend for their operation is known as their costs. Okay, so a cost is how much money does a business actually have to spend. And the amount of money that the customers have to pay them for their goods is called a revenue. So that's how much money that the people actually pay them and that they take in. And when you take the amount of revenue and you subtract the initial cost from them, that's when you get the profit. Okay, so the first question says when a company is making money, which is the goal, the profit will be positive. What is the relationship between revenue and cost when this happens? So revenue must be greater than the cost, because if you have a positive profit, then that means that they're taking in more money than it's costing them. Okay, moving on to the next page. So this is a spreadsheet. This can be kind of a little bit confusing if you don't know how to read it. So this comes right from an Excel document that was created, and it's talking about a business about snow cones, and this entire next section is going to be dealing with this particular problem. So it says if they sell, if you look here, snow cones sold. So they sell 0 snow cones, it costs 0 cups, it costs 0 cups, it takes 0 syrup, but they still have fixed costs involved. So basically what this is saying is that it takes them $245 just to run this business, which means that they have a profit of negative $245 because they didn't sell any snow cones. If they sell 100 snow cones, then this is the cost associated with it, and if you go across, then they would have a net profit of 182, and so on. So it's asking if 300 snow cones were sold, how many ounces of syrup are needed? What about 500? Well, I'm going to go to 300. Go to the syrup column. That's where I got 600 ounces, 500, got 1,000. Now, question 3 is asking you to write a formula that you would put into Excel. This I'm not really too concerned about, but basically you would put in, if you were wanting to make a formula in Excel, you would do equals to this asterisk star times cell A5. And reason why we're doing 2 times is because 300 snow cones was 600 ounces of syrup. 500 snow cones was 1,000 ounces of syrup. So what is the relationship between those two? Well, they're double the amount of syrup than snow cones sold, which is why we're multiplying by 2. Question 4, write a verbal description of the relationship between the number of snow cones sold and the number of ounces of syrup. Well, the number of ounces of syrup used is twice as big as the number of snow cones sold. So if you complete the sentence, we're going to do 2 times x, which is the number of snow cones. And we can write this as a formula. So we're going to use S represents the number of syrup. So syrup is equal to 2 times the number of snow cones. So that's the equation that we are going to be using. Okay. So question 7 is saying, does the number of snow cones sold depend on the amount of syrup used, or does the amount of syrup used depend on the number of snow cones sold? You have to ask yourself, which one sounds better? The amount of syrup depends on the number of snow cones, right? Because if they don't sell any snow cones, then they're not going to need to use syrup. So that's why it goes like that. So if it asks you, what is the independent, what's the dependent, for question 8, the independent is the number of snow cones, which is x, and the dependent is the number of syrup, which is the variable s. All right, so moving on to question number 9. Is the relationship between the amount of syrup used and the number of snow cones sold linear, exponential, or neither? It is linear because they are always going to be going up by the same amount. The amount of syrup needed will always be double the amount of snow cones sold. So it makes it a linear function. And it says, question 10, if x represents the number of snow cones sold, what quantity described in the spreadsheet would be represented by 5x? So 5x means we're taking the number of snow cones sold and multiplying it by 5. So if we go back up to the spreadsheet that was originally given, we have to look which of these numbers is 5 times the initial amount of snow cones. Well, 100 times 5 would be 500. 200 times 5 would be 1,000. 300 times 5 would be 1,500. So if you look, the ice has the numbers that we're looking for, which is where where I got this from, the number of ounces of ice needed, because ice is 5 times the number of snow cones sold. Okay, so a lot of this is going right back up to that spreadsheet. Question 11, if 70 snow cones are sold, the value of 5x is blank. Well, we know that it's 5 times the number of snow cones, so 70 times 5 is 350. And what does it tell us? It tells us that 350 ounces of ice are needed to make 70 snow cones. Question 12, if you were to graph the data in a column, A and J from the spreadsheet, the number of snow cones and the horizontal axis, and the total cost, what would the graph be aligned? How can you tell? So yes, the graph would be aligned because the costs are always going up by a constant rate as the number of snow cones increases. So that means that this must be a linear graph. So because it's always going up by the same amount, it's going to be linear, okay? And if you look at the graph, so it says snow cones, 100, 200, 300, 400, total cost. This is how much the snow cone people have to pay. And we're going to plot those points. I wasn't paying attention to the numbers and I plotted the graph along, so ignore that line. This is the correct line. So initially, if we look up here back at the spreadsheet, total costs, we're looking down at this column J. It starts at $245, $257, $269, $281. Those are where these numbers came from that I plotted. Okay, so we're taking the numbers from J and those are the numbers that we're plotting in the total cost. Yes, it forms a line. Well, what is the y-intercept? 0, 245. That's the initial. If they sell 0 snow cones, it costs them $245 to run the business. Okay, write a unit rate that describes the combined costs. So to find the unit rate, remember unit rate is the same thing as slope, okay? So we're kind of calculating that. So it says $12 per 100 snow cones. The costs go up $12 each time, right? And where does that come from? If I go back up to the chart, 245 plus 12 is 257. 257 plus 12 is 269. 269 plus 12 is 281, and so on. All right, so that's where this comes from. So it says $12 per 100 snow cones. If we divide those two numbers, we get 12 cents, 0.12, okay? And remember, this was $12 per 100 snow cones. So this is really 0.12 per 1 snow cone, which is our unit rate. So the unit rate is 12 cents per snow cone, okay? And we can find this out using slope as well. So these are just two different ways of figuring out the same information. So here, I picked any 2 points. I just happened to choose the first 2 points from that table, 0, 245, 100, 257. I subtract the y's, I subtract the x's, you get 12 over 100, which looks familiar, and you divide, you get 12 cents. It is the exact same thing as the unit rate. So when a question is asking you to find the unit rate, it is the same thing as calculating the slope, okay? You could do it either way. But just know, question 14, finding the unit rate was easy because it was out of 100, right? The questions are not always going to be using easy numbers like that. So slope is probably the easier way to determine the unit rate. Question 16, if each cup costs 1 cent, 1 penny, 0.01, what is the expression for the total cost in dollars of cups based on X? Well, 0.01 times X, because X is the number of snow cones. Question 17, if 4 cents is spent on syrup for each snow cone sold, write an expression. 0.04 times the number of snow cones, 0.04 times X. If 7 cents is spent on ice for each snow cone sold, write an expression. 0.07 times X. Okay, now we're going to use for question 19 the answers we got from question 16, 17, and 18. So it's saying the total combined supply costs for making 1 snow cone looks like this. Cost of cups plus the cost of syrups plus the cost of ice. Those are the costs that the company has to pay just to operate their business. So I'm going to add those 3 together because those are all things that this company has to pay. 0.01 plus 0.04 plus 0.07 is 0.12. X. Notice it's just X. I did not put an exponent of 3 there because we're doing addition. We're not multiplying. So there's no changing of the exponent. It's just 0.12X. Okay. Question 20 says the total cost of selling snow cones is the sum of the variable cost for supplies, which we just found. So that's 0.12X, and the fixed costs. those are the costs that aren't affected by the number of snow cones sold. So rent, insurance, licensing, etc. So how do we find the cost? Well, the cost of this company have to be, well, how much do they have to pay for rent and insurance and all that stuff? We know that that's $245, okay? That was told to us. If they sell 0 snow cones, they lost $245. That's their fixed cost. But they also have to pay 12 cents per snow cone. So this right here, 245 is my fixed cost. 12 cents X is my variable cost. That's my changing cost. This is going to change depending on how many snow cones they sell, because if they only sell 5 snow cones, they only need 5 cups. But if they sell 300 snow cones, they have to use 300 cups. So whatever number is the one that's dependent on what's being sold or what's changing, that's the number that's always going to get your X. Okay, the fixed cost will never have an X because that number is never going to change. And we add them together, which is equal to a cost. Okay, question 20 is a super important concept. If you're struggling to where this equation come from, please reach out to me, because this is something you're going to have to be able to write these equations by yourself. And I know that this is a really challenging concept, so please reach out to me if you're struggling on this. All right, I did the did you get it? Do it, try and see if you get the same answer as me, because this is such an important concept. All right, and that concludes the classwork section. So once you finish going through this video, I want you to try the group work on your own, because it'll give you an idea of what you understand. You guys do have contact information to each other. Reach out to the other students in the class. See if you guys can work through problems together just like you normally do in class. And once you finish the solution, check out the next video on the 3.2 group work to see how you did, and make the corrections as necessary. Again, please reach out to me if you need. The homework for 3.2 is going to be due next class by 9:30 a.m. So again, the homework's going to be posted on Blackboard. Just make sure you submit your homework into Blackboard. And again, reach out to me during office hours if you need.